So usually what are the plates of capacitor they should be made up of? They should be made up of conducting, the plates must be conducting. So, and due to rise in temperature, so definitely the area of cross section of plate will change. Then there'll be effect on the capacitance. So how to maintain still the same capacitance? And capacitor is a device which we use widely in most of the applications. Any small change in capacitance, it will have impact on the total performance of equipment. So this diagram, it is actually like this. This is the plate. Try to work out more some mixed concept problems also. These are the leads. They have shown some curve like this. Don't get confused. This is that spacer. So how to nullify the effect of temperature on the varying capacitance? Means though temperature increases, still what should happen? The capacitance should not change. Shall we take insulating plates? So this is alpha 1, this is alpha 2. This is having area of cross section A. This is, I think, this is that spacer. This is a plate, this is a plate. Okay, now I think you are able to get an exact picture. No change in capacitor with change in temperature. So what is the basically capacitance we define? F naught A by D. D what happen? I'll maintain fixed here. As I increase due to increase in temperature or due to change in temperature, it's a conducting plate. So usually plate what happen? They're made up of conductors, iron or silicate. They're conductor. So conductors are sensitive to the variation of temperature. So area of correction will change. So then there'll be impact on the capacitance. The capacitance, if temperature increases, area of correction of plate will increase. Proportionally, capacitance will increase. But this should be constant. So what I should do now here? Area of correction anyway is going to change. Proportionally will change the D. What type of spacer I should consider? Shall I consider the conducting spacer or non-conducting spacer? So what should be the condition for this spacer? If it is a conductor, capacitance will become infinite. So the spacer rod pen should be a non-conductor and it should be sensitive to the temperature also. And it should, its particular volume rod pen should vary with the temperature. So there's a condition for the spacer. It should not be a conductor. It should be insulator only. It should be electrical insulator. I'll write it. So condition for spacer, it should be electrical insulator and good conductor of heat. Then only it will fit up. if if this is a metal, then the capacitance will become infinite. So let me differentiate this dc by, or directly you go for this one small fraction error in dA by A plus, or say so go for delta, D again symbol, delta C by C should be equal to delta A by A plus delta D by D. What is delta C by C? This should be equal to 0, no? Delta A by A should be equal to beta into delta T, beta 1 plus delta D by D. It's only length. It's only length, that one. So here minus. So what should be the beta 1 should be equal to alpha 2. So what is beta 1? 2 alpha 1 should be equal to beta, no? Thermal expansion concept. Okay, there's a relationship between them. If this condition is satisfied, as the capacitance, though temperature varies, it should not change here. Now, why I took here negative? Due to area of cross section, capacitance what happen will increase. Then the increase in capacitance should be nullified, no? So if I increase this proportionally, so that what happen, the change in capacitance should be nullified, no? Okay, friends, so some anywhere problems can be asked for you. Huh? You should be very careful. Okay, tomorrow we'll continue remaining. Thank you all of you. Any doubts you can clarify related to today.